Here we have a 3D rendering showing the PIPS protocol. This unique tip design is lowered into the coronal portion of the tooth being endodontically treated until the tapered and stripped portion only is submerged into the fluid-filled access opening. Note that it is not necessary to place the tip down into the actual canal. This first SEM photo shows the smear layer present immediately following canal preparation after conventional filing. As we continue virtually downward into the canal, note that the placement of the PIPS tip stays stationary above the canal. The laser energy is activated into the tip, creating a series of shock waves traveling down the entire root canal system to its apical terminus. As this photon-induced photoacoustic streaming activity of the PIPS mechanism continues, a flushing of smear layer and debris can be seen exiting upward from the canal up into the access opening in the coronal aspect of the tooth. This action has been demonstrated over and over in both experimental test models and clinical trials during the irrigation portion of treatment. The resulting surfaces shown by our SAM studies have demonstrated extremely clean surfaces that leave the dentinal wall surfaces uniquely intact. In fact, due to the non-ablative and remote, distant from the apex, mechanism of action with the PIPS laser protocol, our SEM microscopy has demonstrated both hydroxyapatite and even collagen fibers to remain intact and undisturbed morphologically. Traveling further down the canals, we see evidence of lateral canals that are well cleansed and void of tissue and smear layer. The remaining canal preparations show efficacious removal of debris from the entire canal system. This process can be done with less need for over-instrumentation and is extremely minimally invasive. The final preparations offer the clinician a more biomimetic surface for obturation and restorative adhesion.